This is section 10.4. We are in the home stretch. One more section to go after this. This section's on equations in quadratic form. So equations like these two are not technically quadratic equations because their highest power isn't a 2. However, they are in what we call quadratic form. That means that we can make a substitution of the smaller exponent variable and we get an equation that is a quadratic. All right, so here's what we're going to do. This is in quadratic form. If I make a substitution, and I'm just going to use the letter u for this, and I let u be that middle variable, that x squared. If I do that, then u squared would be this x squared squared. So if I make this substitution and then I square both sides, I get that u squared is x to the 4th. So this equation, if we make that substitution, this x to the 4th becomes u squared. Minus 7, I'm going to substitute this x squared with u, plus 12 equals 0. That is a quadratic. You can solve this by factoring, completing the square, or using the quadratic formula. So it's always about making that correct substitution. Now, this substitution is not something I just yanked out of my butt. It does end up being this kind of middle one here when they're in descending order. Okay, so let's go down to this right here. I'm going to solve this one by factoring. So I factored these two. This is a trial and error, so I just want two numbers that multiply to give me positive 12 and add to give me negative 7. So that was negative 3, negative 4. Splitting those two up and solving it, I get u equals 3 and u equals 4. Now here's the thing though. This part of the problem is familiar to us. We've been solving quadratics in this way. The substitution is what's new, but also when I'm done, look what I've got. I didn't circle these. Those are the u answers. I'm solving this for x. So here's what you have to do. You have to remember that you're not done, and you have to plug x squared back in for u, because that's what our substitution was. So I have to take x squared equals 3 and x squared equals 4, and then continue to solve it for x. So in doing that, remember u equals 3, u equals 4. So I substituted back in. I used red for that substitution. If you use the square root property on both of these are both set up for square root property, you get plus or minus root 3, and plus or minus root 4, which simplifies to be 2. So we have 4 solutions to the equation. We have 1, 2, 3, 4. All right, so we have root 3, negative root 3, 2, and negative 2. We knew there was going to be 4 solutions because the highest power is 4. So I made a note of that up here. That's the number of solutions. So that's something to kind of note in polynomial equations. Those are the ones that have those nice exponents that aren't like fraction exponents and stuff. So if you've got a nice, whole number exponent, this is a nifty little thing to notice. All right, so here's what we're going to do. We're going to make this substitution. We're always going to let u equal that middle variable part. And then if it's in quadratic form, if I square u, I'm going to get this first variable part here. That's going to give me a quadratic that I'm going to have to solve by factoring, completing the square root property. Once I get that solved, I'm going to have to resubstitute back in for my original variable. So once I get those u answers, I will have to plug back in the thing I substituted, u4. And then solve again. And in this case, the thing that I had to solve was yet another quadratic. Sometimes when you do this, it may result in something messier. let's look at another one here. Let's do another one here. Very similar to the last one. Notice that 4, that's whispering sweet nothings into your ear, and it's telling you how many solutions we're going to have. So that's a good thing to notice, because if you stop too soon, when you get those U answers and you only have 2 answers, you know that you've done something wrong because you should have 4 answers. All right, so here's my substitution. There's U, there's U squared. So this equation with my substitution becomes this. So I now have to solve this by factoring, completing the square, or the quadratic formula. I chose to factor out a 2, divide both sides by 2 if you want to. I chose not to. I chose to just leave the 2 there. If you wanted to divide both sides by 2 and get rid of it, you could. And then I factored this. With this one, if you tried to take 2 equals 0, there's no variable to solve for here. So there's no solution that comes from that. If this had a U, then there would be a solution for that. So we get U equals -2, and then U equals -3. All right, let's resubstitute back in. These are my U answers. We want the answers for X. So my U was X squared, so I'm going to substitute X squared back in for U. And just like before, I'm going to take the I'm going to use the square root property to take the plus or minus square root of both sides. Now here's where this one is a little bit different, because look, I've got a negative under that radical for both of these. That's going to give me an imaginary answer for both of them. So these are my 4 answers. I have I root 2 and negative I root 2. Those are 2 answers. And then I have 2 more answers over here, I root 3 and negative I root 3. So there's my 4 answers, 1, 2, 3, 4. If you wanted to get, really crazy, you could check your answers. You could take I root 2 and substitute it back in for X. And raise it to the 4th power, multiply by 2. Oh, and I am yawning tonight. Plus 10 times, I root 2 squared plus 12, and you should get 0. It's kind of messy. I'm probably not going to recommend it. So let's do another one. It's going to have a slightly different form, but it's still going to be a quadratic form. All right, so we have x to the 2/3 minus 4x to the 1/3 minus 21 equals 0. I'm going to make that substitution for that middle variable part. In doing so, that's going to be my U squared. That's because if you take this x to the 1/3 and you square it, you multiply the 1/3 times the 2 and you get 2/3. So basically, if you see any kind of junk like this, just know that that middle one's going to be U, and then that bigger one's going to be U squared. So there's the form. I factored it. 2 numbers we multiply to be -21 and add to be -4. Split those apart, got my 2 answers for U. Now how many answers am I going to have? 2/3 answers? No. That trick of how many solutions only works for polynomials, which means only works for the ones that have these nice whole number exponents. So we get this U equals 7, U equals -3. I'm going to substitute back in. Remember back up here, U was 1/3, or sorry, x to the 1/3. So my dog's got the zoomies tonight, and she managed to go find a squeaky toy. So if you hear that, that's what that is. I much prefer the squeak toy and the zoomies to her cleaning her butthole as thoroughly as she possibly can. So we get U equals 7, U equals -3. Substituting back in for that x to the 1/3 power, we get x to the 1/3 equals 7, and we get x to the 1/3 equals -3. Now this is kind of weird, right? How do you solve an x to the 1/3, right? Well, x to the 1/3 is the same as a cube root. Remember those? The opposite of a cube root is a cube. So what I can do is raise both sides to the third power. And honestly, what I'm really doing is I'm just raising both sides to that reciprocal power. And I'm telling you that just, oh my gosh. I know I should restart this video and try it again without all the yawning and the squeaky toy and stuff. But yeah, here we are. This is how it really is. I'm really just using this 3/1 because it's the reciprocal of 1/3. And remember, from our exponent rules, if you have a power raised to a power, you multiply them. So 1/3 times 3/1, you just get x to the first. So we get 7 to the 3/1, or 7 cubed. Just use your calculator. And then this one, to the 3/1 power, so that's -3 cubed, is -27. So there's my two solutions. So you don't always get 4 solutions. Sometimes with those rational exponents, you're only going to get 2 solutions out of it. All right, let's do another one with some rational exponents, because I know those are pretty messy. All right, pretty standard issue here. We're going to let u be that middle variable, and then u squared is going to be the first one. So that substitution produces a much nicer quadratic. At this point, we can factor this, complete the square, or use the quadratic formula. I chose to factor it. So we wanted two numbers who multiply to be 40 and add up to be -13, so -5 and -8. So for me, factoring is a lot faster than the quadratic formula on some of these kind of smaller ones, you know, the ones that have a 1 right here. Oh. All right, if we split those apart, we end up with u equals 5, u equals 8. You're not done. Don't stop there. Those are your answers for u. You're solving for y. This one was nice enough to tell you how many solutions you were going to have. Sometimes in Hawks it does that. So those are not the 2 solutions. Those are u. You have to substitute back in for y. So y to the 3/2 was my u substitution. So I'm going to substitute this u right here for y to the 3/2. So I got y to the 3/2 equals 5 and y to the 3/2 equals 8. How do we get rid of a 3/2 power? Well, I'm going to raise both sides to the 2/3 power. Why is that kind of blurry? There we go. That's a little bit better. So I'm going to raise both sides to the reciprocal. So this blue stuff is the reciprocal of that exponent. So we get 5 to the 2/3 power and 8 to the 2/3 power. Now how do you do this? I'm going to take my calculator out of the drawer over here. Well, you do 5 raised with the fraction bar 2/3. All right, so that's not something that's, you know, super duper nice. So we get about 2.92. 8 raised to the 2/3 power. That was just 4. That's because, remember, the 1/3 power is a cube root. So that's a cube root of 8, which is 2, and then 2 squared. Remember, exponent over root. Whereas this one's a cube root of 5, nothing pretty, squared. So it's the same as a cube root of 25, if you were to write it exact. For a lot of these, though, Hawks will allow you to write approximate answers. So, woohoo! Okay, let's do some that have negative exponents to them. Let's find the 4 solutions for this. All right, you know the drill by now of what to let u and u squared equal. So we end up with that very pretty quadratic. We're going to factor this. We want 2 numbers who multiply to give us +10 and add up to be -7. So that's going to be -5 and -2. So remember, this is section 6.2, the prerequisite stuff. If you're struggling with that factoring, you can always go back to that prerequisite material and refresh your memory. Okay, so splitting those apart, we get u equals 5, u equals 2. Those are the u solutions. As in, you were not done. You're solving for x. So I have to come back over here and take those u answers and substitute x to the negative 2 in for u. Now ignore the blue stuff for now. For right now, I just put x to the negative 2 equals 5, x to the negative 2 equals 2. The blue stuff was me getting rid of the negative 2 power. So remember how every single time in those previous ones when I've used this blue stuff, I've used the reciprocal, right? So this negative 2 is negative 2 over 1. So if you take its reciprocal, it's negative 1/2. So I raised both sides to the negative 1/2 power. That gives me x, those cancel, or those two undo each other. And I get 5 to the negative 1/2, and x equals 2 to the negative 1/2. All right, so let's talk about some things here, because some stuff is going down. All right. Number 1, how in the heck did I get from here to here? Is probably what you're wondering. And where did this plus or minus come from? Ooh. That's because this is, if you think of this as kind of like a squared, because it is, it's 1 over x squared, we're kind of using the square root property here. And we're taking the plus or minus square root of both sides. So why didn't I do this with any of the other ones? Well, that's because the other ones didn't have that squared square root relationship going on there. This one is a little messier. Let me just grab another piece of paper here and show you some of the details. So if we take this x to the negative 2 equals 5, this means 1 over x squared equals 5. Now the way I could have done this, I could have said, okay, well that means x squared over 1 equals 1 over 5. I can just flip to 2 fractions are equal, then the reciprocals are equal. So if this is true, then this is true. So I get x squared equals 1/5, and now I can just use the square root property. So taking the square root of both sides, the plus or minus square root of both sides, I get that. That might be a little easier now that I think about it. I kind of wanted to stick with the same way that I was doing it, using that reciprocal, but then once I brought in that plus or minus, I realized that it turned into kind of a hot mess. So with this particular negative exponent, it might be easier to just rewrite it as a positive exponent. Now, again, how did I get from here to here? If 2 fractions are equal, if we say that a over b equals c over d, then their reciprocals are also equal. So it means I could take the reciprocal of both of these and maintain that equality. And then of course we know that over 1 just kind of goes away. All right, I can do the same thing over here for the other one, right? I had x to the negative 2 equals 2. Right, u equals 2. So same thing. 1 over x squared equals 2. I just rewrote that negative exponent as a positive exponent. And then just flipping both of these fractions, I get x squared equals 1/2. Using that square root property, taking the plus or minus square root of both sides, I get that. So my 4 solutions are these. However, they're not simplified. All right, they're not simplified, so I have to simplify them, which means I have to rationalize them. What's wrong with it? There's a radical in the denominator, and you know how it is. We can't have that. So I do have to rationalize those, which I did over here. So you can see that I went from here to here, because I rewrote that negative 1/2 power. So everything that happened up here is just a different mathematical way of getting to the same place that I did here. I just wanted to show you this stuff in case this made more sense. Because when I first wrote it up, I was like, oh, okay, yeah, I can do that and stick with that same reciprocal business. But then as I was explaining it just now, I'm like, maybe not. Maybe it doesn't make as much sense. So we get those 4 answers. We do have to rationalize them. So picking up where I left off on that separate piece of paper over there, I'd have to, this becomes plus or minus the square root of 1 over the square root of 5. Notice I didn't write the square root of 1 because it's just 1. And then I'm going to rationalize it by multiplying by that square root over itself, and I get plus or minus 1 root 5 over 5, because that's the square root of 25. So there's 2 answers. Going down here, I get plus or minus the square root of 1 over the square root of 2. Rationalize that by multiplying by that denominator over itself, and I get plus or minus 1 times the square root of 2, I don't have to write that 1, over the square root of 4, which is just 2. So there's my other solutions. So those 2 and those 2. So again, if you want to pause it just to kind of digest what just happened here, and then what happened over here. This is the long version of what I did in these 2 steps. And then this is just me rationalizing it. So at this point, like right about in here, if you wanted to go to that separate paper that I just used and forget about all this, you can. If all this kind of makes sense and flows for you and it's not too much and too overwhelming, then hey, that's cool too. That one is pretty messy. All right, keeping the fun going here. You know the drill, u squared. Now look, this one, find the 1 solution for. Oh no, 1 solution, that's going to be interesting. See how that thing's going to play out. All right, this one factors pretty nicely. 2 numbers that multiply to give you negative 66 and add to be 5. So we factor it, split those factors and solve it, and we get u equals 6 and u equals negative 11. U was y to the negative 1/2. So there's that y to the negative 1/2 equals 6, y to the negative 1/2 equals negative 11. This negative 1/2, so let's do it like I did this last one. Let's rewrite it as 1 over that thing to the positive power. Negative 1/2, 1 over that thing to the positive power. Remember what 1/2 power means. It means the square root, right? So 1 over the square root of y equals 6. Over here I get 1 over the square root of y equals negative 11. There's no solution for this. There's nothing that I can take the square root of and get a negative answer. Now don't get this confused with I can take the square root of a negative number and get it imaginary, but I cannot take the square root of anything and get a negative answer. It's always positive, so there's no solution for that. So that means my only solution is going to come from this one. All right, so remember there was no solution for that part. So I get this 1 over the square root of y equals 6. Remember how I said that you can take the reciprocal of both sides? So you can think of this as 6 over 1. If 2 fractions are equal, fraction equals fraction, then you can take both of those fractions and flip them. So flip that fraction, and maintain that equality. And then you can just kind of ignore that 1. All right, so we get the square root of y equals 1/6. That's not the square root property. The square root property takes the square root of both sides. This, I'm going to square both sides. So I get y equals 1 over 36. There's a lot of stuff in here that I can completely understand is confusing because it all kind of sounds the same, right? You're like square, square root, those all really sound the same. So I can see where some of this is going to be confusing, and that's really why I'm doing so many examples, all right? Because I know this video is long, I'm already looking at the time, I can see it, but I want you to have plenty of different problems worked out so that you can have plenty of things to reference as you work through these, okay? All right, this one, who-wee. All right, I can let u be that middle stuff, and then that's u squared. Now here's the kicker for this one. You don't even have to do this one this way with substitution, all right? You could just multiply, distribute all that stuff out, and then just get a normal quadratic, but in any case, here's where we're at. So we get u squared plus 23u plus 126. That factors into 14 and 9. Split those apart, we get u equals negative 14 and u equals negative 9. U was the same thing as 2y plus 5. So substituting back in for u, I have 2y plus 5 equals negative 14 and 2y plus 5 equals negative 9. Now both of these right here, that is a two-step equation. That's a two-step equation. Both of these equations, I'm going to subtract 5, divide by 2. No funny business, no square root in both sides, no square in both sides, no negative 1/2, 2/3 power, none of that crap. So subtract 5, divide by 2, and get my two solutions of negative 19/2 and negative 7. I realize that negative 19/2 is kind of smushed together there. It might be hard to see, but negative 1/9 over 2 and negative 7. Okay, last one. Like I said, I'm doing a lot of these, not because I just, love them. I mean, they are kind of cool, but mostly just so you have a little bit of everything. Y to the 4th minus 25. Now, this one's really tricky because there's no middle term. So here's what we have to do. We have to bring in that middle term. That middle term that's not written is a y squared. Now, how did I know it was going to be a y squared? Well, because I know that this big one is my u squared. So this one must be my u. That means that this exponent is always half of this exponent. Okay, so did you catch that? This exponent, this middle one, is always half of this exponent in these quadratic forms. And then I put that coefficient of 0 in there. So this gives me this u squared plus 0u minus 25. I had to bring in that term in order to get this kind of standard quadratic form. This factors into u minus 5, u plus 5. That gives me the two u solutions of 5 and negative 5. Substituting back in for u, we get y squared equals 5 and y squared is negative 5. All right, those are just the square root property because I've got, something squared equals a constant. So both of these are the square root property. Take the plus or minus square root of both sides, and we get plus or minus root 5 and plus or minus root negative 5. We know that that I underneath there is going to, that negative under there is going to come out from under that radical as an I. So there's my four solutions. Root 5, negative root 5, I root 5, negative I root 5. Okay, I know this was kind of long, but I hope that having a whole bunch of different types of problems will help you to have a reference for all the different problems you're going to see in Hawks. So this concludes section 10.4.